What up, YouTube? Hey, this is Smitty again with a video. I'm going to do a video about brain-derived neurotrophic factor because I recently realized that stretching can actually improve the nervous system. And why is that important to me? Well, I was hit by a car while cycling. I lost feeling on the half side of my body, and the doctor told me to do some serious stretching of my hamstrings, and I didn't know what he was talking about. I didn't do it. Many years later, I realized that if you stretch, you can actually improve things like pain tolerance and also immobility, right? So I used to walk with a cane, and I don't walk with a cane any longer. Um, and I recently attributed my recent success to being able to walk a little bit better without a limp to brain-derived neurotrophic factor. And actually, I realized there are other neurotrophic factors that play a role, and I'm trying to figure out like what they all are and what role they play. And also, I know that IGF-1 plays a role in stretching. So stretching may stimulate IGF-1, for example. So I asked my friendly ChatGTP-enabled app about some neurotrophic factors, and I actually have an article on it on iHeartGains. And the title of the article is "Stretching and Neurotrophic Factors: Mechanisms, Functions, and Sources." And so it talks about how stretching is a common exercise that has been shown to have numerous benefits for the human body. One of these lesser known benefits of stretching is the ability to promote the release of neurotrophic factors in the body. Neurotrophic factors are a group of proteins that play a crucial role in supporting the growth and survival of neurons in the brain and nervous system. In this article, we will define and describe the mechanism by which stretching promotes the release of neurotrophic factors in the human body, list the various neurotrophic factors, and articulate their role in supporting the growth and survival of neurons in the brain and nervous system. So this one I'm going to concentrate on today is called glial cell line-derived neurotrophic factor. And the other ones are nerve growth factor, brain-derived neurotrophic factor, and ciliary neurotrophic factor. So about the glial cell line-derived neurotrophic factor. So I asked my friendly ChatGTP-enabled app, I was like, what are glial cells? Cite relevant sources in MLA format. Glial cells, also known as neuroglia, are non-neuronal cells that provide support and protection for neurons in the nervous system. There are several types of glial cells, including astrocytes, oligodendrocytes, and microglia, which each with their own unique functions. Pervez et al. 2018. Astrocytes are the most abundant type of glial cells in the brain and are involved in regulating the chemical environment around neurons, providing structural support and contributing to the formation of the blood-brain barrier. Oligodendrocytes are responsible for producing myelin, a fatty substance that insulates axons and facilitates nerve conduction. Microglia are the immune cells of the brain and are involved in responding to injury and infection. Fields is the source from 2019. So Pervez is from 2018 and Fields is from 2019. And I apologize in advance for any mispronunciations of any names or anything in this video. So we know what glial cells are. They are non-neuronal cells that provide support and protection for neurons in the nervous system. So there is this thing called glial cell line-derived neurotrophic factor. So I asked my friendly ChatGTP-enabled app, does stretching promote the release of glial cell line-derived neurotrophic factors? Cite relevant sources in MLA format. There is some evidence to suggest that stretching may promote the release of glial cell line-derived neurotrophic factor. A study conducted by Matsunaga et al. 2016 found that stretching increased GDNF levels in the blood of healthy adults. Another study by Hada et al. 2018 also observed an increase in GDNF levels in the blood of individuals who perform stretching exercises. And the two sources are Matsunaga from 2016 and Hada from 2019. I wanted to find out a little bit more about glial cell line-derived neurotrophic factors, so I asked my friendly ChatGTP-enabled app, what is glial cell line-derived neurotrophic factor and how is it activated? Asked it to cite relevant sources in MLA format. Glial cell line-derived neurotrophic factor is a protein that plays a crucial role in the survival and maintenance of neurons in the central and peripheral nervous systems. It is a member of the transforming growth factor beta, TGF beta superfamily, and is produced by both glial cells and neurons. GNF exerts its effects by binding to a specific receptor known as GNF family receptor alpha, GFR alpha, which is expressed on the surface of target cells. The sources is Ixinin and Sarma, 2002. GNF is activated by a process called proteolytic cleavage, which involves the removal of a propeptide from the N-terminus of the protein. This cleavage is mediated by a specific enzyme known as co-convertase. Polito Salgado et al. 2015. And here are the sources is Erickson 2002 and Polito Salgado from 2015. So it talks about proteolytic cleavage. I'm not sure exactly if this is associated with this, but proteolytic cleavage is part of a process in which GDNF is formed. So I asked my friendly ChatGPT-enabled app, does autophagy involve proteolytic cleavage? In the site relevant sources in my format. The reason why I'm asking this question is because sometimes when I fast, I walk with less of a limp. And when I've just eaten, sometimes I may have issues. And I've also found that, when I fast and I'm on a ketogenic state, I had fewer issues with walking, right? And I tend to be less hungry, and the hunger response isn't there. But when I tend to ever have to be in a situation where I'm hungry, my nervous system seems to be affected negatively. So I asked my ChatGPT about autophagy, and this is what it says. Yes, autophagy involves proteolytic cleavage. Autophagy is a cellular process in which cells degrade and recycle damaged unnecessary cellular components. This process involves the formation of autophagosomes, which sequester cellular components and deliver them to lysosomes for degradation. Levin and Kramer, 2019. Within the lysosome, the cellular components are broken down by lysosomal hydrolases, which are proteases that cleave peptide bonds in proteins. This proteolytic cleavage is essential for the degradation of the cellular components and the recycling of the resulting amino acids. And this source is Levine and Kramer, 2019. So there you have it. So autophagy plays a role in proteolytic cleavage. We know that. And proteolytic cleavage is involved in the glial cell neurotrophic factor production. So we know that to be certain, right? There seems to be less information on what glial cells do and their benefits. And I'm going to do a little more research and come up with another video. I did an earlier video on stretching. I'm going to refer to that and see if I can combine brain-derived neurotrophic factor and glial cell formation and see how they may both play a role in helping people restore their nervous system and brain cells. Anyway, that's it for this video. If you need help reaching your fitness goals or wellness goals even, seek a fitness professional. If you want help from me, there's resources in this video, on this YouTube channel, and at iHurricanes.com. I'm Smitty. I hope you reach your fitness goals, and I'll talk to you next week.